Hello everyone, welcome back to Trigonometry Graphs. What we are going to be looking today is how do we interpret and understand and how to draw all those type of things when we are shifting vertically. So meaning the graphs are moving up and down. They're not necessarily stretching. Have a look at what I'm going to do here. Say for instance, this is my axes. They're not necessarily stretching like becoming longer like that, which we'll look at in the next video. However, they are just moving up. So say for instance my graph is like this, all of a sudden they will be shifting, going up and just having the exact same shape but just moving up or moving down. So that is what the whole lesson is about today, or in this lesson. Okay, why don't we jump right in? So what we're first going to look at is we're first going to look at the sine graph, the cos graph, and then below is a tan graph. And we're going to look at, firstly, what does the sketching look like? I'll just explain how do we understand it, and then we're going to look at these four important words that are so important. Remember, domain, range, period, amplitude, and I'm going to explain it in detail. So let's have a look at our first one. So the first thing that is happening, our first graph that we're looking at is the normal sine graph. So you know that the first one that I showed you is when you just have y is equal to sine x. That is the simple as simple as you can get. And then when you start putting other things like plus 5, then it will shift, okay? And if you start putting numbers in the front like 2 sine x, then it will start to stretch and become a bit wider. So what I'm trying to say is I first showed you just the normal sine of x graph, and now in red we are going to look at what does a graph look like when we have specifically something added or subtracted to it. Okay, so today's lesson is all about when I have a y equals whatever, like a cos graph, what happens when I have minus 3 or plus 2, what happens? And that is what today's lesson is about. You'll see what happens is that when you have a plus or minus a number, the graph simply moves up or down. Okay, if it's plus, it's obviously moving up. If it's minus, it is moving down. So let's go and have a look at how we how that actually happens. So let me just get my laser out. So in the black, guys, black represented by the sine x, the red graph will be represented by the sine x plus 1. So we know that in the previous video, I think it's the first video that I made, the normal sine graph starts like this. So if you put sine of 0, you get 0, and then if you put sine of 90, you get 1, etc. And you go and you fill in the graph, and this is the normal graph. Now what happens, I can actually get my calculator out quickly. Now have a look here. When I have sine of not just 0 but sine of 0 plus 1, now look what happens. Instead of sine of just putting 0, I put plus 1. What did I end up getting? I ended up getting the answer of 1. So can you see that it has shifted up 1 unit? And I'm just going to take 2 more examples to show you, to prove what I'm mentioning, and then I'll carry on. So let's take a sine of 90. So originally sine of 90 gives me 1, but if I put that into the calculator, if I put sine of 90, but now remember we plussed a 1 afterwards, I should be getting 2. So have a look here. Instead of getting 1 where my original graph is, this original one, I plussed 1 and I get 2. So can you see that basically the graph is literally shifting up 1 unit. Every point that you have plotted on your original graph, sine graph, has been going up by 1. So that is what happens, guys. That's what I'm trying to emphasize, is that when you have y equals sine of x and plus q, or it can even be if it's minus q, plus or minus whatever, it is just shifting the graph up or down. Okay, that is what's happening. Let's have a look at what happens when we need to answer questions about domain. Okay, let's have a look here. So sorry, I zoomed out. I was supposed to zoom in. So let me get my laser out. Let's go and answer what is the domain, range, period, and amplitude. If you missed that video, guys, I made a whole video on just what these 4 words mean. So please go and watch that in detail. It has a lot of detail and explains it in detail for you to completely understand what these words mean. So we're gonna go and compare how do I answer these questions: the domain, range, period, amplitude for sine of x, the black graph, and then the sine of x plus 1, the red graph, the graph that has shifted up 1. Okay, I hope you had that in your mind. So let's do the domain. Sorry, I need to zoom out because it's a little bit squished here. So let's do the domain of the domain of the black graph. So the original. So you can see it's going from negative 360. I've already taught this. It's going all the way through. So it's x is the element of or belongs to from negative 360 all the way through to 360 and including them. And then for the red graph, it's the exact same. It's also going from here all the way. It's going all the way through. So x does belong to the degrees from and including negative 360 all the way through to 360. Let's have a look at our range. Okay, so with regards to the range, what's going to happen is for the black one, remember you ask yourself, you look at the y value. So where's the minimum y value? It's -1. So the minimum value of the black graph is from -1. So it touches there and then it goes all the way. What is the highest point that the black graph will touch? Well, you can see it is 1. Over here touches and over here. So the range, the y values exist from and including -1. So I put -1 and +1. Now guys, the answer does change for the red graph. The y values exist not from here. Please look at that. Can you see in the red graph, the y value does not go to -1 at all. It moves up and the minimum value is now 0. Can you see that? I hope you can. So it's going from 0 and including 0 all the way up to 2. The highest point is now 2, and that is how you write it over there. Let's have a look at period. Remember in grade 10 I explained your period will always be 360 for the sine and cosine graph, so that's simple. Now for the amplitude, well, I already explained there's a shortcut that you can use to get your answer. For sine and a cosine graph, the amplitude is if you don't remember, I said the amplitude can be the number in front of the sine or the cos, so there's an imaginary 1 here. So you can just basically get the answer from there. Or I told you that you can use this little formula. So you take the maximum value of the y for the original, so it's 1, and then minus the minimum value, so minus a -1. So that will end up becoming 1 plus 1 is 2, so 2 divided by 2 is 1, and you get your final answer anyway. Same thing over here, guys. So maximum value is 2, minimum value is 0, so 2 minus 0 gives me 2. 2 divided by 2 is 1, and that's how I get 1. So there are 2 ways of doing it. I hope that's helpful. Right, so that brings me to the end of how do we understand vertically shifted the sine graph. And next video I'm going to be looking at the cosine graph.